Here's a probability situation where instead of writing out a specific sample space, we're given information that allows us to decide how many outcomes satisfy certain events. The first thing that we're told is we're looking at the next 32 trials coming up. And they're then divided into categories based on offense: 5 homicides, 12 drug offenses, 6 assaults, 9 property crimes. Jurors are assigned randomly, which is what tells us that we can use our probability experiment rules because it's a random assignment. The question is, what's the probability that a juror gets assigned to a case that is not a drug offense? So in our probability notation, we could write this as probability of not drugs. There's really 2 different ways you can handle this. The straightforward way is to recognize that if something is not a drug offense, it has to be one of the other 3. So it could be either a homicide, an assault, or a property crime, which tells us that there are 20 offenses that are not drugs out of the 32 total. So the probability of not getting a drug offense for this juror is 20 out of 32, which reduces to 5/8. The other option here is to use our rule for complements. And the point is that the probability of getting a trial that's not drugs is going to be 1 minus the probability of getting a trial that is drugs, because the trial being for a drug offense is the complement of the trial not being for a drug offense, and this is our rule for complements. The probability of getting a drug case is 12 over 32, because we're told that 12 of the cases are drug offenses out of the 32. Now I have a simple subtraction of fractions, and I get 32 over 32 minus 12 over 32, which is 20 over 32. That also fortunately reduces to 5/8, so I get the same answer either way, which is always a good thing.